Greetings to everyone. Want to move on right away to sets. And sets normally use the symbols of the square root, but within the inset, when it's a square root, we do not write the value 2 over there. But when it's cube root, we bring the 2 and so on. But these are special values like square root of 3. You can't actually get its real value like square root of 4. So when it happens that what we do is that we group them under sets, square root of 2, square root of 3, square root of 5, and so on. So we want to see how we can simplify some of these. And so right away, we'll be looking at that. And so that is how we will be dealing with this. So straight, I want to see how we can add the following sets. So we have this and that cube root, this cube root, and that square root. So we want to add them. So we'll actually group the like terms or try to solve the like terms, and then when we finish, we get our final value. So square root of 3 times cube root of 3 plus 4, cube root of 3 minus 5, square root 3. So this and that will be considered together, and this and that will be considered together. So you get 1 over here, and get negative 5. So when we do the computation, we shall get negative 4 root 3. And over here, we have 1. So 1 plus 4 will give us 5 root 3. So if we add the following sets, then this is the value that we will actually get. Right. Now, from there, we want to look at another example. It says, express square root 50 as the simplest possible set. So we look at square root of 50. From our previous lessons under indices, we saw that if you want to find a square root, you look for 2 factors that will multiply to give you the value here. And so as this one stands now, we want to look at it. So we have 25 times 2 under this. So we'll split them. We have square root of 25 times square root of 2. Now, this is straight away a set. We can actually get a simple value right now, unless we get it in decimals. So, but square root of 25, we'll get 5. So write it as 5 root 2. Sometimes we can go ahead and give you the value of square root 2, and then you can now multiply. So as of now, we'll leave our answer this way. So that's how we express some of these things in their simplest form. The next question that we want to consider says expand the whole of this. So whatever I have in this bracket is multiplying what we have in that bracket. So we'll do them in tens. So we write our expression. So 2 times 5 will give us 10. 2 times 2 root 3 will give us 4 root 3. So the 2 times 2 and then our root 3. Then move on to the next term. Negative 4 root 3 times 5 will give us negative 20 root 3. So 4 and then 5. And then the next step is that we are going to multiply this term and that term. So negative 4 times 2 will give us 8. And then root 3 times root 3 will give us 3. And so when we do that, then straight away we multiply negative 8 by 3, and that gives us 24. Now I want to now group the like terms and then simplify them. So we have our positive 10 and negative 24. So we'll get negative 14 for this and that. And when we come, we have 4 root 3 and negative 20 root 3. So they are like terms. So this 4 will clear that, and then we'll get 16 root 3. And so that is how we expand this one. You take your time and do them in tens, and then you simplify by combining the like terms. So we see all the root 3s as like terms, and then we see the whole numbers as also like terms. So this is the value that we get when we want to simplify or expand this expression. Right, so we'll move on to the next one. Over here, what we are going to do is that we've been asked to simplify this For us to simplify this, we'll go through what we call rationalization. For us to rationalize this expression, we pick the denominator and find its conjugate. So the conjugate for this will be that we write 2 minus 3 root 5. So they multiply the numerator and the denominator by that. So we pick the conjugate set of the denominator, we multiply the numerator and denominator by the original expression. So that is what we are going to do. Now, so we pick this one, and as we did in the previous example, we multiply them in 10. So 4 times 2 gives us 8. 4 times 3 will give us 12, and then root 5. The negative root 5 times 2 will give us negative 2 root 5. Negative 5 times negative 3 root 5 will give us our 3 times 5, and that will give us our value over here. So basically, what we are going to do is that we will have our 3 times 5, because root 5 times root 5 will give us our root 5. Then at the denominator, we'll multiply them out. So 2 times 2 will give us 4, and then 2 times negative 3 root 5 will give us 6 root 5. And then 3 root 5 times 2 will give us positive 6 root 5. Then 3 times negative 3 will give us negative 9. Then root 5 times root 5 from indices will give us 5. Then we try to simplify both the numerator and the denominator. Now over here we have our 8. Then we have 3 times 5, which will give us 15. So when we add it to our 8, then we'll get 23. Over here you have negative 12. Then we have our negative 2. So we'll get negative 14 root 5. Now, if you look at the denominator, you see that negative 6 root 5 will clear negative positive 6 root 5. So negative 6 root 5 plus positive 6 root 5 will clear. Then we get 4 minus 9 times 5. Now, if you look at it, you see that it obeys this principle that we have down here. Anytime you are multiplying a set and its conjugate, you get this squared minus that squared. And so that's the concept we view here. So henceforth, you can decide not to bring what we have in the middle. All that you do is that you pick this, square it, you pick that, you square it, and then you find their difference. And so when we simplify this, we carry out the rationalization processes, and finally we get this value. So it will be 4 minus 45, and then that will give us our value over here. So we get 23 minus 14 root 5 over negative 41. So take note of this expression. Thank you for your attention. Bye.